Thank you. So, hi everyone again. Thank you for coming. And today I will speak about micro frontends. So, let's start. First thing, anyone remembers this guy? Anyone still using PHP? Yeah. So, we have PHP. We also have had Rails. We built full stack applications just using Rails PHP. Then we had, and we still have jQuery, then Ember, Backbone, Angular version 1. And people are trying to migrate from those technologies, and they're having a hard time with it. And some people, when you say that you work with PHP or Rails, they have this reaction. And people usually like something new, something like React or Vue.js or some new versions of Angular. And as I said, sometimes it's really hard to deprecate some technology that's making you some money, but you as a developer are reading those fancy new articles, and you also want to use something new, and that's hard. But now we can. So today I'd like to present you the micro frontends, and I want to show you how to easily migrate from old technologies and how to scale your front-end applications. So I'm Ivan. As you heard yesterday, I work at Nearform. We do stuff with JavaScript. We maintain a bunch of open source modules. We also maintain Node.js. And you can find more about me on Twitter and on my blog. So what are the micro frontends? Micro frontends, simply said, it's a microservice approach to the modern web. So if you're not familiar with microservices, let's see what are the microservices. That's just an architectural style that structures your application as a collection of loosely coupled services. So that looks like this. Those are 3 Node.js services. They just communicate together and they create an app. And since we want to make them loosely coupled, so they don't need to explicitly register one with another, we are adding event bus between them, so they can just exchange messages using some event bus service. And simply, event bus is allowing us to have that publish-subscribe style and between the components without requiring them to explicitly register one with another. And that's exactly what we want for our microservices. So some microservice principles are, we want lightweight protocol between services, so something that's small, fast. People usually go with REST API and using HTTP protocol. I also recommend using event bus and some async event-driven services. Then you want to have small services, and we want to have one job per service, which will allow you to faster develop them, test them, so easily onboard new people. Then you have the service independence. That means that your services are really independent application that can be run independently, but when you deploy them together, you get one big system. And as I said, there should be easier to understand, develop and test, and you will be able to, to scale easily with the microservices. And it's speeding up development, so decoupling stuff is usually a good idea when it comes to the development speed. It also enables you to have really continuous delivery and deployment. Whenever you have a new service, whenever you make some changes, you will just deploy that change service, and the whole app will still work. Comparing that to monolith, when you change just one line of code, you need to run whole build, you need to deploy that big monolith app, and that usually takes some time. And also, if just one service goes down, you can just replace it. It's really simple. So again, this picture, this is what we have in backend. So we have Node.js apps, and it would be great if we can do something like this. So if we can have our React applications running together on the UI, or even better, if we can combine them. If we can have React, Angular, Vue.js, or any other framework running in our UI independently, and then creating the whole front-end app together. So some talk like which one is better, Angular or React or Vue.js, we can change the topic to how to make them work together and what are the best practices with combining them. So we're coming to the part where we can say that we want to have microservices everywhere and we want to decouple backend but also the front end. So how that really looks like in the UI. Simply we have just one app which has header, body, and footer. And we can replace that with, we will call the main app root app. And all those header, body, and footer can be separate applications running on any framework, any library. So we will have header will be app 1, body will be app 2, app 3 will be footer. They will be independent apps, deployed independently. They will work. The code will live in the separate repo, and different developers, different teams will can work on them separately. So. So how did we get here? Now we are talking about micro frontends or microservice architecture in the UI. So first, we had monolith full stack apps. So we used PHP Rails for building the full stack applications. So we didn't separate them on front end and back end. So next thing that happened, we separated them. So we had front-end, back-end applications, and then some HTTP protocol between them that allowed us to exchange data between client and the server. Then we decoupled back-end. So we wanted smaller apps in the back-end to easily scale. And then React came, and we got components in the UI. So that was one way of decoupling stuff on the client side. And now we have micro frontend, so even more decoupling in the UI too. And this is because we want to fight with bad architecture. So you probably worked in a company where after some time, the CEO and the CEO starts adding more money and hiring more people, but you are not delivering as much as everyone expects, and that's usually because you have some things left behind. You know those stories, we will fix that later. That's why we are trying here to decouple our stuff so we can give independence to our teams and they can work on their problems independently. So what problems does micro frontends architecture solve? First, you can use new framework, new libraries on some old architectures really easy. There are no more shared code bases and conflicts between developers. So if you worked on Angular 1 and I worked in a company, we used Angular 1 and there were 30 developers working on that same app and we had conflicts all the time. So we had 20 pull requests opened in just one code base with a lot of merge conflicts, and that really slowed us down and we had big problems there. And it would be better if we just decoupled applications into smaller apps and give independence to the team and freedom to develop. So you have independent deployments. So same thing that we have in the back end where you can just fix one service, deploy just that service. The same thing you can get on the UI. So if you have, for example, chat application running in your UI and some typo was made there, then developer from the chat team can just update the app, deploy it, and then you will just need to refresh your browser and you will see that new version of just the chat application running in the UI, which will also be faster since the ESLint or tests will be just run on a small code base. And you're giving the freedom to the teams to pick their own stack. Probably in your company you're arguing what framework should we use. Now you can give freedom to developers and to other teams to pick what they like, what they want to work at. And you can easily scale your app. So by decoupling stuff, you have people working independently, and you will be able to scale really easy and finally in the UI world. So how to split applications. Usually people split them by functionality on the page. If you looked at, for example, Gmail, the list of the emails is one app, the Hangouts list is a different app. If you take a look at the Outlook app that Microsoft builds, even the when you hover some name of the person and you get a pop-up showing some details about him, that's also a micro app, so separate app running on React that just being embedded inside the big UI. So you can also split that by page. So people also do that. Every different page on the app can be a different app. And you just need to have the global router that will render pages render apps depending on the URL. Next thing, you can separate them by sections. So you saw we can have header, sidebar, body, footer running on a different framework and being a different app. So implementation. I have a list of couple ways how can we really implement this. So first thing is external app bootstrapping. This is not a real name. I just made it out since there is no framework behind this. It's just some simple code that allows you to run multiple apps. Then you can use iframes. So everyone is using iframes probably in their apps. You can still use them to run the micro frontends. There's a library called single SPA. That's the open source Node.js library that allows you to combine different frameworks and bundle them and deploy them as a one app, but they're really multiple small child apps. And free framework. So single SPA is a small library just allowing you to combine frameworks. Free framework is a framework, so you get a bunch of different things there. Like they give you a solution how to exchange messages and how to exchange data between your services. So let's go from the first one, external app bootstrapping. So here we have, here code lives on a different server. So you will, every team which works on some child app will create a bundle, so JavaScript CSS bundle. And that will be deployed independently, so independent deployments. That will be deployed independently on a server. And then your main app will just be taking that JavaScript and CSS code, injecting that into the main UI, and then rendering the application. So probably on just one page, you might have different applications running at the same time, and you want to exchange some data there. So you can just use window object, or you can use an event bus. So there are a bunch of libraries that are allowing you to have the same experience like I have in the back end, where we use some event bus to exchange messages. You will have the same experience in the UI too. So how the code looks like, this is basically fetch app method. That's the only thing that you need, and this code will be running in your main app and will be used to fetch different apps from different servers. So this method is just taking an element, so it can be ID or a class of a div where you want to render the app, the base URL, so the URL where your code for the child app is living, and some files that you want to fetch. So usually it's main CSS, main JS, but you can also override that. And inside function, this is the most important part. We're just going through the files here, and if a file is a JS, we're just using some jQuery Ajax to inject the JavaScript inside the app. And if it's CSS, we are just appending the link with the URL of the CSS file. And that's it. So with this done here, so done on the line 10, that's how we mount our app. So the global will contain so fname will be the function that's being exported by the child app, and then with the global fnm, and then passing the element, and that way you're rendering the JavaScript code that you fetched into the DOM. So remember this, so we have global fnm element. Let's see where's that coming from. If you have, for example, React app, usually just import React and render, and then you're exporting the default function with an element argument, and you just want to render the code, render the React component inside inside the DOM to an element with ID or class that's coming from the argument element. And in your main.js, you just want to export this named global app, just equal app. And when we're back here, on line 10, the code we call global app and then pass the element, and that's how the code will be rendered on the page. So really simple. There's no library for this, and this is the only thing that you need. So just the fetch app module that you can write, and then on your main app, you will just call fetch app with element and base URL for your child app that you want to render for each child app. And that's also how I came to the idea to create this. I worked in a company where we had a really big Rails app, and we wanted to have some nice UI, some nice interactions to give to the user. And we wanted to use React, but since you have the app, a really big app with 20,000 tests running on the full stack Rails, there wasn't some simple way to just inject React. And we created something like this. So it really helped us to decouple stuff and to create some new pages that when the Rails mounts up, it will just fetch React code, render that, and it will look like the whole app. And the user wouldn't know that that's really micro-frontends usage. I said that we can use event bus when you have, on the same page, when you have different applications and you want to exchange data between them. You can use event bus called EEV. So it's open source module, really simple. It has less than 500 bytes. And I think it says something like 100 lines of code, just one file, no dependencies. And it's really fast. It has 0 dependencies, and it's so simple. So you're just getting two methods, and that's it. So you can find it on GitHub. And this is how EEV works. So you will just import it, create a new instance, and you will get 2 methods. One is emit, second one is on. So when you emit some event, the first argument string is just the name of the event that you want to send. And you can send any type of data as a second argument. And then some other app running on the UI will be listening for that event, and we'll have callback function that will be executed when that event comes. And then you can re-render something, you can update the UI, do whatever there. So for making this work with the fetch app idea that I show you, you probably want to put that on a window. So window.e will be accessible by any micro app that's running. And then any app can connect to window.e and listen or send events to the event bus. So next thing, we have iframes. So how to use iframes to have the micro frontends. First thing, it's the same as the previous approach. Code still lives on a different server. You deploy your app independently. You can run your app independently. And using iframes, you're just fetching the apps and putting them together. So same thing, independent deployments, and communication is done through something that I call browser event bus, which is something called window.postMessage. It's already in the browser, and it allows you to exchange messages between the main app and the iframe. Here you just need to send the data that you want to the iframe, and you need to set the origin, so the URL of that iframe, so the browser will know which iframe to hit with that message. And then inside the iframe, you will have event listener just listening for the message that will come. And that's looking like this. So this is, let's say, main app, root app, that's just rendering one iframe and has some code, JavaScript code for sending data to that iframe. That code looks like this. So here you're just making an app constant. That's the content window of the iframe. And then you can post message. First one will not work since our iframe is HTTP example.com. And if you want to hit an iframe with google.com, it will fail since you don't have an iframe with google.com on your page. And this app post message will just send a message to the iframe. And also the same thing, as you can send a message to the iframe, you can also listen for some message that will come back from the iframe. You can also put window.event listener at the bottom of the page, listening for the message. And also the receive message callback that will just check if the origin is correct. So if you really got the message from the iframe that you want, and you will have event.source and event.data passed to you. This is the code that will be running in the iframe app. So here you will just check if the origin is the main app. So if not someone not someone hacking you and sending some messages from different origin, and you can console log the event.source and event.data. So event.data is this will work string that we send from our main app, and inside the event.source. You will have a reference to the root app that's rendering this iframe, so you can use post message to send some message back. Also, in a company where we use the Fetch app, we also use iframes for something. And I know that, for example, Google is using iframes for their Gmail app to render different smaller apps on a Gmail interface, for example. And yeah, this was everything for the iframes. Let's go next. So I said there is a simple library called single SPA library, and the single SPA library is also open source, living on it's on a GitHub, and it allows you to use multiple frameworks on the same page without refreshing that page, and you can easily just integrate any of the application that you already have. And it doesn't depend on any framework, so you can integrate any framework that you already have into the single SPA and just group those applications really easy, since there's a small amount of the boilerplate code that you need to use. And it allows you to lazy load the apps. So you will be able to write your own method to say whenever you want, so when you want to render the page. If you want to listen for the history API to see when the URL changes, or you, for example, want to listen on the window.scroll event. So if you have some big app and you first render, for example, 2 pages, since that's what the user can view. And then when he starts scrolling down, you can fetch and mount those pages that are not visible on the first load. It gives you unlimited possibilities here. And as I said, it's on single SPA module is on GitHub. And here, code lives on the same server. So you will be bundling your code into one bundle, and you will be deploying that as a one app. Yeah, everything is bundled and deployed at the same time. So for the communication, you have a lot of options here. So you can use window object, just putting stuff inside the window and then taking that in different app. You can use EV event bus. You can also have shared state, so we are introducing Redux here, or anything else that you want to use. And then you have global Redux that will be used by all the micro apps rendered on the page. And yeah, you can use whatever else you find. That will definitely work with a single SPA. And single SPA looks like this. So you will just import single SPA from the single SPA. And here we just want to render one app. So we're having the app name, loading function, and activity function. And we declare our application inside the single SPA by passing those 3 variables, and you call single SPA start. So the app name, so just the name of the application that you want to render. The most important thing here is the loading function and the activity function. So the loading function looks like this. It's used for the lazy loading. And here you just pass the import of the code where your micro app is living. And activity function is telling a single SPA when to render your app and also when to import it. So here you're listening for the location hash. So if the URL changes to #/app1, the single SPA will render your app. Also, as I said, you can listen for anything else. I was also listening for the window scroll, since it helped me to improve the page load. And yeah, at the bottom, so as I said, we're just declaring the new child application and calling the single SPA start to start the single SPA instance. And for every child application, you will need to pass those two functions and the app name and to call declare child application. And that's one part of the boilerplate that you need to have inside your root app. And inside your single SPA, so inside the child app, you will need to export those three things. So bootstrap, mount, and unmount, probably familiar to you if you're building front-end apps now. Bootstrap is just used to prepare the, let's go, yeah. Bootstrap is used to prepare the UI for rendering your app. So here we're just creating the new div. So you don't even, with single SPA, you don't even have to manually create a div. It can be done with the Bootstrap, with the JavaScript code here. So we're just creating a div with the ID app1, and we are creating that element inside our DOM. For the mount, basically you're mounting your app there when the activity function says that. So it should return a promise, it should resolve, and then we're just here putting some text into this div, but you can also render the React Angular Vue.js app here inside the DOM element div that you have. And the unmount, so it's also good when you mount an app and when you change the page or the activity function is returning false, it should unmount your application and save some space and memory. So here we're just removing everything from the div. Single SPA has a bunch of sub-modules that allow us to use React, Vue.js, and Angular. So for example, here, this is single SPA React module that just gives you some code for easily bootstrapping, mounting, and unmounting the React app. So you have the single SPA React method. You just pass React DOM, the root component that should be rendered, and DOM element getter. So the function that will return reference to the div where you want to render your app. And then you can simply export bootstrap, mount, and unmount. And that's it. So you will need to do this for every React app, but it's good that you can easily just take any React app that you already have, just take single SPA React, fill those 4 arguments, and that's it. You will be able to render your React app inside some bigger root app. Same thing we have for Angular. So just pass the main module, the template that you want to render, and the Angular router, and that's it. You will have bootstrap, mount, and unmount method exported. And we also have this for Vue.js, which is the simplest. Just pass the element where you want to render, and pass the template that you want to render, and that's it. You will have bootstrap, mount, and unmount. And also the guys who created single SPA created, I think, 20 or more different modules for different framework and libraries that you can use. And if you have some new module, some new framework that you want to render, and there is no module for helper for rendering it, you can just write your own. It's really simple. Single SPA, I think, has like 500 lines of code, so it's small and simple to understand and use. And the last thing from the implementation list is Frint. And actually, I found this like 1 month ago. Frint is living on frintjs.org. You can find it there. And it gives you a CLI. So it's really a framework where you have CLI to create the new project, and you have the CLI to create any other smaller child app that you can use, and they will immediately connect. You have routing, so it immediately gives you the routing for your main app and child apps. And you have the state management inside there, so you have Redux running there. And it's also supporting the server-side rendering. The only thing that it doesn't support is Angular, so it only works with React and Vue.js now. Yeah, some faces. I was talking with the guys, they will try to support it, but for their needs, since one company is standing behind this and they're using Frint on a bunch of their projects, they're just using React and Vue.js. And Frint, so as it says here, it's a modular JavaScript framework for building scalable and reactive applications. And you can just install it, Frint CLI, globally, and you will be able to use the free CLI, for example, to create a new project. And they have a bunch of examples to go with. Just pass the example and the name of the example that you can find on GitHub, and it will install it. And one more good thing is that it uses reactive programming. So it gives you a reactive programming paradigm to use to exchange data between your apps. If you're familiar with reactive programming, you know that it's just working with asynchronized streams of data. And that's exactly what Frint gives to you. So any of the child components will be able to connect to the stream and to put data there, and then other apps will be able to listen to that and get the data and re-render. And one also good thing is that it works with the React Native. So if you want to build a React Native app and you there want to use micro frontends, which is awesome, then you can use Frint for that. It's supporting React Native, and you can find a bunch of examples on their website. And yeah, so here we are. We're almost done. So today, who's using micro frontends? And I was talking with a bunch of people, so I found that Google is using micro frontends a lot. Even Microsoft, which is usually those companies that have a really big amount of employees working on the same things, are just decoupling their UI too to give them freedom to work independently on the apps. And also that Facebook is using it too. Even the like button that you have is a separate app that's being fetched and injected on the page. And yeah, and many more. So I found that everyone is kind of using it, and they don't know that they are using it in some way, which is really great. So what we learned today, if you have some simple app, like some blog or something like that, or some static page, you really don't need this. This is made for bigger companies, for bigger teams, where they have bigger apps with a lot of interactions. For example, you have a hotel booking website, that's an amazing use case, or a flight booking website. Yeah, try to use micro frontends to make things easier, not complicated. So the same thing that we have with the backend architecture, where people are making their apps more complicated by integrating microservices. Try not to do that on the UI too. So make things easier, decouple where you think that it should be good to be decoupled. And micro frontends architecture doesn't mean that you need to use every new framework that comes up. So you're browsing Hacker News, you saw that some guy created a new framework. Yeah, let's just integrate that. But don't do it. It will be a bad idea. So create your own stack, create the frameworks that you like, the libraries that you want to use, and then just use them across different micro apps. And yeah, don't forget to make standards across the apps. So try to have the same ESLint configuration. For example, if you use for example, Jest or Mocha for running tests, try to use them on all applications. It will help developers who are going through the different projects and different teams to just jump in and understand the whole architecture immediately, since you're just using the same thing as every other team is using. And yeah, that was everything I had for today. Thank you.
Thank you, Ivan.